the correct answer by matching the list 1 and list 2. In the list 1, there is a detail about the transition of atom. Whereas in the list 2, there is a detail about the corresponding wavelength during a transition. So we can use the energy difference to find the wavelength for each transition by using a formula E is equal hc divided by lambda. And also we can compare the relative energy difference based on the transition values, since the higher energy difference is shorter the wavelength. Or else we can say E is inversely proportional to the wavelength lambda. It's known that the energy difference in the hydrogen atom during a transition can be calculated using a formula del E is equal minus 13.6 times 1 over N1 square minus 1 over N2 square in terms of electron volt. In the list 1, in option A, the atom is moving from orbit 3 to orbit 2. So here del E will be equal to minus 13.6 times 1 divided by 2 square minus 1 divided by 3 square. When we are simplifying this, we will get del E is equal negative 1.89 electron volt. Similarly, we can calculate the energy difference for the option B, where the atoms are moving from 4th to 2nd. So here del E will be equal to minus 13.6 times 1 divided by 2 square minus 1 divided by 4 square. When we are simplifying this, we will get del E is equal negative 2.55 electron volt. Similarly, for option C, the atom is moving from 5th orbital to the 2nd orbital. So here del E will be equal to negative 13.6 times 1 divided by 2 square minus 1 divided by 5 square. When we are simplifying this, we will get del E is equal negative 2.856 electron volt. Similarly, for option D, the atom is moving from 6th orbit to 2nd orbit. So del E will be equal to negative 13.6 times 1 divided by 2 square minus 1 divided by 6 square. When we are simplifying this, we will get negative 3.022 electron volt. So now we have a transition energy value for option A, option B, option C and option D. As I said already, the energy and the wavelength are inversely proportional. Since the energy and wavelength are inversely related, the larger the energy difference, the shorter the wavelength. From the energy difference we calculated, we can say the transition D is having a larger energy difference, which means it will have a shortest wavelength. When we are checking the list 2, the shortest wavelength is option 1. So here we can match option D from the list 1 to option 1 in the list 2. Similarly, option C has the second highest energy difference, so it will have the second shortest wavelength. So when we are checking the list 2, the second shortest wavelength is option 2. So we can match option C with option 2 in the list 2. Next, transition B has a third highest energy difference, so it will have a third shortest wavelength. When we are checking the list 2, option 4 is having a third shortest wavelength. So we can match option B from the list 1 to option 4 in the list 2. Similarly, we can match option A with option 3 in the list. So here the answer will be option D. A will match with option 3. B will match with option 4, C will match with option D, similarly D will go with 1.